So today with transformation geometry, we're going to be initially focusing on three things. It's translation, reflection, and rotation. So there's also enlargement that you need to know. We'll see if we can get to that in this lesson, else we'll do it in another video. All right. So let us have a look, starting out with translation. And I am going to share my screen like this. Very nice, very nice. All right. So for us to use, or for us to go through this sort of stuff, what I'm doing is I'm using a program called Geogebra. Geogebra is one of my favoriteest programs because it's amazing for drawing shapes, but it's also amazing for functions and drawing graphs and stuff like that. And it's very easy to be able to change stuff and see stuff very visually, which helps a hell of a lot. So I'm using this to try and show us how transformation geometry works, what changes about the shape, what you need to take note of, and what will actually happen with it. All right, so this is my translations sheet that I've created for you guys. And what I've done is I've created an L shape. And the most important thing that you need to remember with translations is that you are simply taking the shape and moving it. You're either moving it left or right, or you're moving it up and down. You are not changing the shape. You're not changing the size. You're not changing the orientation, nothing. So we can either move it horizontally, and I've left the brown shape there as a reference from where it starts. So either to the right or to the left. Or you can move it vertically. So notice it's the exact same shape. It's just being moved up, down, left, or right. But more importantly, you can do more than one together. So you can move it up, say, 3 units, and then move it to the right, let's say 4 units. And there you can see it's the exact same shape, same orientation, same size, 1, 2, 3, 4 blocks, 1, 2, 3, 4 blocks, 1, 2, 3, 1, 2, 3 blocks. So it really doesn't matter how you take this combination. It can be anywhere as long as it's the exact same size and it is the exact same orientation. So all that's going to happen is your X value of each of these points is going to change if you're shifting horizontally, and your Y value is going to change if you're shifting vertically. Great. Any questions on that? All right, no questions. So this is the nice, easy one. There's not too much thinking about what to do with this. So then we can move over to our next one, and that is not that one. I want to leave that one for last. That's the same one. It's getting annoying. There we go. All right. So this one is all about rotations. Now, what is rotation? Rotation is where you pivot one point and you move the shape around that point. So in essence, your shape is not changing size, but it is most definitely changing its orientation or direction. So I have put in a way that we are able to rotate it around each point so that we can see the difference that happens with each rotation. All right. So if we want to start with point A, for example, I have put my other color shape over the brown. So here is a kind of pinky magenta shape. And I'm now going to rotate around A. So we can see what's happening is that it's pivoted at A. It's kind of like if you put a drawing pin through at A, through both of the shapes. It can't move its position, but it can only swivel around the point A. And as it keeps swiveling, we see that there are a couple key points. For example, that one, this is 90 degrees. So everything has been moved up by 90 degrees counterclockwise. We can then keep going, and we had this important point, which is 180 degrees. So we now see that every point has moved around 180 degrees. It doesn't matter if A moves around 180 because it can't move. That's the pivot point. This one over here is 270 degrees counterclockwise, or it is 90 degrees clockwise. I feel like I'm getting those directions confused. That's clockwise. That's counterclockwise. Okay. So that one moving this way is counterclockwise, 90 degrees. So you can see the shape is still exactly the same. It overlaps exactly the same. And it's swiveling around point A. All right. What if we want point B, for example? So here I've got my red shape. We can now see the difference. So it's a completely different rotation at 90 degrees now. Because you remember where the previous one was. If I take A, that's where my previous one was. This is where my one is now, according to B. I keep rotating. That's 180 degrees. That is 270 degrees or 90 degrees the other way. And then it comes back to the original place. So same shape, but a very different rotation. What about if we rotate according to point C? So here's my other darker shape. This is now, again, a very different rotation compared to the other ones. And you would expect it to be different because it's a different point. 90 degrees. Once again, I'll show you the other ones. So we had a look at A already. A is over there. So interestingly, from here to there would be a translation because it's the same shape in the same direction. And if we have a look at B, we can see B is over there. All right. So we can see that it's the same, that it's going to, well, the same. It's the same in that each point is going to be different. So I have a question about F. I'm going to get to F now. And let me take off my other one as well. Take off C. All right, so D, there's D. You can see again, very different. So 90 is now all the way up there. That's 180. That's 270. And there it goes around the original again. If we have a look at point E, this is one of the more interesting ones. Note it's just twirling around that pivot point. So it doesn't go out and around the shape again because E is now on the inside. So it's literally just twirling around in the middle on the inside. And then, according to the question, we have point F. There's point F. And it's going to lift all the way up and around. Come back down. And back to the original. And this is one of the reasons I love this program, because you can literally do whatever you want, and you can see it as slow or as quick as you want. And you can have whatever point you want rotating, whatever color you want. It's amazing. So what I'm going to do is I'm going to put all of them on so that you can see, but I'm only going to be going 90 degrees just so that you guys can see how different each one actually is. All right, so I've got point C, I've got point E, I've got A, I've got B, I've got D, and I've got F. Fantastic. There they start all going out. That's quite pretty, actually. That is 90 degrees. And you can see that every single one is different. Again, interestingly though, we would be able to move from each of these rotations using a translation transformation. 180, they go all the way around. 270, they start coming back in. That ended up being quite nice and neat over there. That was quite nice. And they all come and fold back into one. I think that's incredibly cool. All right. All right, so no questions there. So let us now pull up our reflections. So it's important to remember that with reflections, it's just like looking in a mirror. So when looking at reflections, it is crucially important to remember that when looking in a mirror, stuff is the same distance away from the mirror in mirror land. That's what I call the other side of the mirror, in mirror land, as it is to in our land. So if I am an exact arm length away from the camera or from the mirror, then from the mirror into mirror land, I'd be exactly an arm length away as well. And that's what this is showing you here. So I have a pentagon here. And this pentagon is exactly on my mirror line. That means that these points A and B are going to be a distance of 0 away from the mirror, and therefore 0 away from the mirror in mirror land. However, what about point C here? So point C there shows that it's that distance away. And we can see that it's 1 block, 2 blocks, 3 blocks, and it looks like 4 little blocks. So this would be the reflection, 1 block, 2 block, 3 blocks, and then 4 little blocks. So it's exactly the same distance. And it doesn't matter where I put the reflection, because the further away each of these points are to the mirror line, the further away these points in mirror land are going to be. And that we can totally understand. Because if you're standing by a mirror and you step back from the mirror, the person in mirror land steps back as well and is further away from the mirror. The part that generally gets confusing is what happens when my reflection line starts intersecting with my shape. And when it starts intersecting, we see that our reflected image actually starts overlapping with our actual image. So this line here, we used to look at CB as a whole line, and then it would be reflected to there. Now that my reflection line has crossed my line CB, I'm only going to look at parts of it individually. So I'm going to look at from C to my reflection line. Well, that then gets reflected up there. But now this bit over here is now on that side of my reflection line, which means it needs to get reflected to the left-hand side. And that's why this bit there is now reflected down here on that side. Just as that this bit here, this line, vertical line AB, it is 2 blocks away. On this side, it is also 2 blocks away. So no matter how far you pull it, there's always going to be an intersection of the original image and my reflected image on the reflection line here. That is where they're going to cross. That's quite an interesting one because now we've got CB, the whole line on that side. Therefore, the whole line goes on the left. Vertical line AB goes over there. That line AE goes over there. And now this bit that's now on the left, CD, needs to go over there on the right. And DE over there must now go over there on the right. Now that it's just touching each other there, you can see that all the points are now here on the right, reflecting to the left. And each of them are exactly the same distance away from my mirror line. So this sort of thing here or there is not difficult for you guys to see, but often when the shapes are crossed, it becomes a little bit more complicated. And I know that you often struggle with it. So I hope that this, seeing it and seeing how you can break up a shape into smaller bits, deal with it in small enough bite-sized chunks, can help you guys out a lot.